Welcome to Math is Beautiful. In this video, we are solving the complete Chapter 3, Rest and Motion, Kinematics from Concepts of Physics by H C Verma, Volume 1, both objective sections and all 52 exercises. We begin with Objective 1, 13 multiple-choice questions on motion, graphs, and projectiles. Here they are, exactly as in the book. Pause if you would like to attempt them first. Objective 1, Question 1. A motor car is going due north at 50 kilometers per hour. It makes a 90-degree left turn without changing the speed. The change in the velocity of the car is about Option A, 50 kilometers per hour towards west. Option B, 70 kilometers per hour towards southwest. Option C, 70 kilometers per hour towards northwest. Or Option D, 0. What does this mean? Velocity is a vector, so we must subtract the two velocities as vectors, not just compare speeds. The change in velocity is the final velocity minus the initial one. Going north turned into going west, so we draw both and join them. The two velocities are perpendicular, each of size 50. The triangle gives the magnitude, root of 50 squared plus 50 squared, which is 50 root 2, about 70 kilometers per hour. For the direction, the change points from the tip of the north vector to the tip of the west vector. That direction is towards the southwest. Option A says 50 towards west, but that is the final velocity itself, not the change. The change has size 70. Option C says northwest, but the change points south and west, not north. And Option D says 0. The speed is unchanged, but the direction changed, so the velocity did change. Hence, the change in velocity is about 70 kilometers per hour towards southwest. Option B. Question 2. The figure shows the displacement time graph of a particle moving on the x-axis. Option A. The particle is continuously going in the positive x direction. Option B. The particle is at rest. Option C. The velocity increases up to a time t0 and then becomes constant. Or Option D. The particle moves at a constant velocity up to t0 and then stops. What does this mean? On an xt graph, the slope is the velocity, so we read the slope piece by piece. Up to t0 the graph is a straight line through the origin. The slope is one fixed value, so the velocity is constant, not increasing. After t0 the graph is flat. X stops changing, so the particle is at rest from then on. Option A fails, because after t0 the particle no longer moves forward. Option B fails, because before t0 the particle was moving. Option C fails, because a straight line means constant velocity, not increasing velocity. Hence, constant velocity up to t0 and then at rest. Option D. Question 3. A particle has a velocity u towards east at t equals 0 and a constant acceleration towards west. xa and xb are the magnitudes of the displacements in the first 10 seconds and in the next 10 seconds. Option A, xa is less than xb. Option B, xa equals xb. Option C, xa is greater than xb. Or Option D, the information is insufficient to decide. What does this mean? The particle slows down, stops at some time t star equal u over a, and then comes back. Everything depends on where t star lies. Suppose the turnaround comes after 20 seconds. Then the particle moves east throughout, but slower and slower, so the second 10 seconds cover less ground, xa greater than xb. Option C would hold. Suppose instead t star is exactly 10 seconds. The return trip mirrors the outward trip, so the two displacement magnitudes are equal. Option B would hold. And if t star is early, say 2 seconds, the first interval nearly cancels itself while the second interval is a long straight run west, xa less than xb. Option A would hold. All three relations are possible, and u and are not given. Hence the information is insufficient. Option D. Question 4. A person on a straight line moves with uniform velocity v1 for some time, and with v2 for the next equal time. The average velocity v is given by option A, v equals v1 plus v2 over 2. Option B, v equals the root of v1 v2. Option C, 2 over v equals 1 over v1 plus 1 over v2. Or option D, 1 over v equals 1 over v1 plus 1 over v2. What does this mean? Average velocity is total displacement over total time, so we compute both for two equal time legs. In the first leg, time t at velocity v1 covers v1t. In the second leg, the same time t at v2 covers v2t. The total displacement is v1t plus v2t, and the total time is 2t. Dividing, the t cancels, and we get the plane average of the two velocities. Option C is the harmonic mean. That answers the equal distance case, not equal times. And option B, the geometric mean, matches neither case. Hence, for equal times the average velocity is the arithmetic mean. Option A. Question 5. Now the person moves with velocity v1 for a distance x, and with v2 for the next equal distance. The average velocity v is given by option A, the arithmetic mean of v1 and v2. Option B, the geometric mean, root v1 v2. Option C, 2 over v equals 1 over v1 plus 1 over v2. Or option D, 1 over v equals 1 over v1 plus 1 over v2. What does this mean? The same idea, displacement over time, but now the two legs take different times. The first leg of length x at velocity v1 takes time x over v1. The second takes x over v2. The total displacement is 2x over the total time. Taking the reciprocal, 2 over v equals 1 over v1 plus 1 over v2, the harmonic mean. Option A, the plane average, was the equal time case of the previous question. It overweights the faster leg here. Hence, for equal distances, the harmonic relation holds. Option C. Question 6. A stone is released from an elevator that is going up with an acceleration a. The acceleration of the stone after the release is option A upward, option B, g minus a upward, option C, g minus a downward, or option D, g downward. What does this mean? Acceleration comes from the forces acting right now, not from the history of the motion. Once the stone leaves the elevator, the only force on it is its own weight. Nothing connects it to the elevator anymore. So its acceleration is simply g, pointing down, whatever the elevator does. The elevators affected the stone's velocity at release, not its acceleration after. Option A keeps the elevators upward a, but nothing pushes the stone anymore. Option B subtracts the elevators a from g. The stone does not know the elevator's motion. Option C makes the same mixture, pointed downward. The elevator cannot dilute gravity. Hence, the stone falls with acceleration g downward. Option D. Question 7. From the top of a building, ball A is thrown vertically upward and ball B vertically downward with the same speed. A hits the ground at speed VA and B at speed VB. Option A, VA is greater than VB. Option B, VA is less than VB. Option C, VA equals VB. Or option D, the relation depends on the height of the building. What does this mean? Follow ball A. It goes up, comes back to the throwing point, and only then starts the downward journey. Ball arises, stops, and returns to the top of the building. By symmetry, it passes its starting point with the same speed u, now pointing down. From that moment, A's journey is exactly B's journey. Same start, same speed down, same height, so they strike the ground at equal speeds. Option D tempts, but the height h raises both speeds equally, so the relation between them never changes. Hence, the two balls hit the ground with equal speeds. Option C. Question 8. In a projectile motion, the velocity, option A, is always perpendicular to the acceleration. Option B is never perpendicular to the acceleration. Option C is perpendicular to the acceleration for one instant only. Or option D is perpendicular for 2 instants. What does this mean? The acceleration is fixed, g straight down. So we ask, when is the velocity exactly horizontal? Throughout the flight, the acceleration is g downward. Perpendicular to that means the velocity must be exactly horizontal. The vertical component of velocity starts positive, shrinks, and is 0 only at the highest point. Before and after, the velocity is tilted. So the velocity is perpendicular to the acceleration exactly once at the top of the path. Hence option C. Question 9. 2 bullets are fired at the same moment, horizontally, with different speeds, from the same place. Which bullet hits the ground first? Option A, the faster one. Option B, the slower one. Option C, both reach simultaneously. Or option D, it depends on the masses. What does this mean? Split the motion. The horizontal speed and the vertical fall are independent of each other. Vertically, both bullets start with 0 vertical velocity from the same height, and both accelerate down at g. The fall time comes only from the vertical motion. T equals root 2h over g. The horizontal speed never enters, and neither does the mass. The faster bullet simply lands farther away in the same time. Hence, both reach the ground simultaneously. Option C. Question 10. A projectile fired at 15 degrees has a range of 50 meters. Fired with the same speed at 45 degrees, its range will be option A, 25 meters, option B, 37 meters, option C, 50 meters, or option D, 100 meters. What does this mean? The range formula depends on the sine of twice the angle, so we compare sine 30 with sine 90. The range of a projectile is u squared sine of 2 theta over g. At 15 degrees, sine 30 is 1/2. So 50 meters equals u squared over 2g, giving u squared over g equal 100 meters. At 45 degrees, sine 90 is 1, the largest possible. The range becomes u squared over g, the full 100 meters. Hence, the range doubles to 100 meters. Option D. Question 11. Projectile A is projected at 15 degrees and projectile B at 45 degrees. RA and RB are their horizontal ranges. Then, option A, RA is less than RB. Option B, RA equals RB. Option C, RA is greater than RB. Or option D, the information is insufficient. What does this mean? Look carefully. Unlike the previous question, nobody said the speeds are equal. The range depends on 2 things: the angle and also the speed of projection. Here only the angles are given. If the speeds were equal, B would win. But a fast enough A beats a slow B, and equal ranges are possible too. Every relation can occur. Hence, without the speeds, the relation cannot be decided. Option D. Question 12. A river flows from west to east at 5 meters per minute. A man on the south bank can swim at 10 meters per minute in still water. He wants to cross in the shortest time. He should swim, option A, due north, option B, 30 degrees east of north, option C, 30 degrees north of west, or option D, 60 degrees east of north. What does this mean? The crossing time is the width divided by the northward component of his swimming velocity. The flow only slides him sideways. The time to cross is the river width over the north component of his swimming speed. The eastward flow changes where he lands, not when. That is smallest when cosine theta is 1. He should point straight across, due north. Any tilt wastes part of his 10 meters per minute. He will drift east and land downstream, but the question asks for the fastest crossing, not the straightest. Hence option A. Question 13. The ends P and Q of an inextensible string move downwards with uniform speed u. Pulleys A and B are fixed. The mass m, hanging between them, moves upwards with a speed. Option A, 2u cosine theta. Option B, u over cosine theta. Option C, 2u over cosine theta. Or option D, u cosine theta. What does this mean? The string cannot stretch, so the rate at which each string segment shortens must equal u. Each string from M to a pulley makes an angle theta with the vertical. The string shortens at rate u, and that rate equals the component of M's velocity along the string. Solving, Vm equals u over cosine theta. Note it is larger than u. As the strings become more slanted, M must rise faster to feed them. Option D is the classic trap. It resolves the wrong way. The component of Vm along the string must equal u, not the other way around. Hence, M moves up at u over cosine theta. Option B. Next, Objective 2, 10 questions where more than one option may be correct. Here they are. Pause here if you want to try them yourself. Objective 2, Question 1. Consider the tip of the minute hand of a clock over 1 hour. More than one option may be correct. Option A, the displacement is 0. Option B, the distance covered is 0. Option C, the average speed is 0. Or Option D, the average velocity is 0. What does this mean? In 1 hour, the tip goes exactly once around the circle and returns to its starting point. The tip ends exactly where it began, so the displacement, final position minus initial, is 0. Option A is correct. But the tip traced the full circle. The distance covered is the circumference, 2 pi r, certainly not 0. Option B is wrong. Average speed is distance over time, 2 pi r over 1 hour, which is positive. Option C is wrong. Average velocity is displacement over time, and the displacement is 0. Option D is correct. Hence, options A and D are correct. Question 2. A particle moves along the x-axis as x equal u times t minus 2 plus a times t minus 2 squared. Option A, the initial velocity of the particle is u. Option B, the acceleration is a. Option C, the acceleration is 2a. Or Option D, at t equal 2 seconds, the particle is at the origin. What does this mean? Differentiate for velocity and acceleration and substitute t equal 2 for the position. Differentiating once, v equals u plus 2a times t minus 2. At t equals 0, v is u minus 4a, not u. Option A is wrong. Differentiating again, the acceleration is 2a, a constant, not a. Option B is wrong. So the acceleration of the particle is 2a. Option C is correct. And substituting t equal 2 seconds, both terms vanish, x equals 0. The particle is at the origin. Option D is correct. Hence, options C and D are correct. Question 3. Pick the correct statements. More than one may be correct. Option A. The average speed in a given time is never less than the magnitude of the average velocity. Option B. It is possible that the magnitude of dv by dt is non-zero, while d of the magnitude of v by dt is 0. Option C. The average velocity is 0 in an interval, yet the instantaneous velocity is never 0 in it. Or Option D. The same, but for a particle moving on a straight line. What does this mean? Distance versus displacement and turning without changing speed. Circular motion will settle most of these. Distance covered is always at least the magnitude of the displacement, so dividing by time, average speed is at least the magnitude of average velocity. Option A is correct. In uniform circular motion, the speed never changes, so d of the magnitude is 0. But the direction keeps turning, so dv by dt is non-zero. Option B is correct. One full lap of that circle, the displacement is 0, so the average velocity is 0, yet the speed was never 0. Option C is correct. But on a straight line, returning to the start means reversing direction, and reversing continuously forces the velocity through 0. Option D is wrong. Hence, options A, B, and C are correct. Question 4. An object may have Option A, varying speed without varying velocity. Option B, varying velocity without varying speed. Option C, non-zero acceleration without varying velocity. Or option D, non-zero acceleration without varying speed. What does this mean? Speed is the magnitude of the velocity vector. The vector can change by turning even when its size is fixed. If the speed varies, the magnitude of the velocity varies, so the velocity certainly varies. Option A is impossible. But the velocity can vary with fixed speed. Uniform circular motion turns the vector without stretching it. Option B is possible. Acceleration is itself the rate of change of velocity. If A is non-zero, the velocity must be changing. Option C is impossible. And in that same circular motion, the acceleration points to the center, non-zero, while the speed stays fixed. Option D is possible. Hence, options B and D are correct. Question 5. Mark the correct statements for a particle on a straight line. Option A. If velocity and acceleration have opposite signs, the object is slowing down. Option B. If position and velocity have opposite signs, the particle is moving towards the origin. Option C. If the velocity is zero at an instant, the acceleration should also be zero there. Or option D. If the velocity is zero for a time interval, the acceleration is zero at any instant within it. What does this mean? Sign reasoning on one axis. Check each claim, hunting for a counterexample. Opposite signs of v and mean the acceleration opposes the motion, so the speed decreases. Option A is correct. If x is positive and v negative, the particle moves in the negative direction, towards the origin. The mirrored case also points at O. Option B is correct. A ball at the top of a vertical throw has velocity 0 for 1 instant, while its acceleration is g, not 0. Option C is wrong. But if v stays 0 through a whole interval, its derivative inside that interval is 0 too. The acceleration vanishes there. Option D is correct. Hence, options A, B, and D are correct. Question 6. The velocity of a particle is 0 at t equals 0. Option A. The acceleration at t equals 0 must be 0. Option B. The acceleration at t equals 0 may be 0. Option C. If the acceleration is 0 from t equals 0 to 10 seconds, the speed is also 0 in this interval. Or option D. If the speed is 0 from 0 to 10 seconds, the acceleration is also 0 in this interval. What does this mean? Zero velocity at one instant says nothing about the acceleration at that instant. Test each claim. A ball released from rest has v equals 0 at that moment, yet a equal g. So the acceleration need not be 0. Option A is wrong. A book lying at rest has v equals 0 and also a equals 0. So the acceleration may be 0. Option B is correct. If a stays 0 for 10 seconds, the velocity cannot change from its starting value of 0. The speed stays 0. Option C is correct. And if the speed is identically 0 over the interval, v is constant there, so its derivative, the acceleration, is 0. Option D is correct. Hence, options B, C, and D are correct. Question 7. Mark the correct statements. Option A. The magnitude of the velocity equals the speed. Option B. The magnitude of the average velocity equals the average speed. Option C. The speed is always 0, but the average speed is not 0. Or option D. The speed is never 0, but the average speed is 0. What does this mean? Instantaneous quantities agree. Averages differ because distance can exceed displacement. At any instant, speed is defined as the magnitude of the velocity vector. Option A is correct by definition. Over an interval, though, the distance along a winding path exceeds the straight displacement, making average speed exceed the magnitude of average velocity. Equality fails in general. Option B is wrong. Average speed is total distance over time. If the speed is always 0, no distance accumulates, so the average is 0. Option C is impossible. And if the speed is never 0, distance keeps growing, so the average speed is positive, never 0. Option D is impossible. Hence, only option A is correct. Question 8. The velocity time plot for a particle on a straight line is shown. A straight line starting at 20, crossing 0 at 10 seconds. Option A. The particle has a constant acceleration. Option B. The particle has never turned around. Option C. The particle has 0 displacement. Or option D. The average speed in 0 to 10 seconds equals the average speed in 10 to 20 seconds. What does this mean? On a VT graph, the slope is the acceleration and the area is the displacement. Read them off. The plot is one straight line, so its slope, the acceleration, is one constant value. Option A is correct. At 10 seconds, the velocity crosses 0 and changes sign. The particle turns around there. Option B is wrong. The positive area before 10 seconds is outweighed by the growing negative area after it, so the net displacement over the plot is not 0. Option C is wrong. From 0 to 10, the speed falls from 20 to 0, average 10. From 10 to 20, it grows from 0 to 20, average 10 again. Option D is correct. Hence, options A and D are correct. Question 9. The figure shows the position of a particle on the x-axis as a function of time. Option A. The particle has come to rest 6 times. Option B. The maximum speed is at t equals 6 seconds. Option C. The velocity remains positive from t equal 0 to 6 seconds. Or option D. The average velocity for the total period is negative. What does this mean? Rest means slope 0. Count the flat moments and watch where the curve rises or falls. The curve flattens at every peak and every valley, 6 such moments in the plot. The particle came to rest 6 times. Option A is correct. At t equals 6, the curve is near a turning point where the slope is small, not maximal. Option B is wrong. Between the peaks, the curve comes DOWN, so the velocity is negative in those stretches before 6 seconds. Option C is wrong. And the curve ends higher than it starts, so the net displacement is positive, making the average velocity positive, not negative. Option D is wrong. Hence, only option A is correct. Question 10. A particle's acceleration, as seen from two frames S1 and S2, has equal magnitude 4 meters per second squared in each. Option A. The frames must be at rest with respect to each other. Option B. The frames may move, but neither is accelerated with respect to the other. Option C. The acceleration of S2 with respect to S1 is either 0 or 8. Or option D. It may be anything between 0 and 8. What does this mean? The two measured accelerations differ by the relative acceleration of the frames. A vector triangle of two sides of length 4. Frame accelerations combine as vectors. The particle's acceleration in S1 equals that in S2 plus the acceleration of S2 relative to S1. So the relative acceleration is the difference of two vectors, each of length 4 at any angle. Its size ranges from 0 when aligned to 8 when opposite. Option A forces the frames to rest, making the relative acceleration exactly 0, just 1 point of the range. Option B allows motion but no relative acceleration. Again, it pins the value to 0. And option C allows only the two endpoints, 0 or 8, missing everything between. Hence, any value from 0 to 8 is possible. Option D. And now the exercises. 52 questions covering straight line motion, graphs, free fall, projectiles, and relative velocity. Here is the full list, exactly as in the book. Pause here if you would like to attempt them first. Then let us solve them, one by one. Question 1. A man goes 50 meters due north, 40 meters due east, and 20 meters due south to reach a field. Part A, what distance does he walk? Part B, what is his displacement? What does this mean? Distance adds every meter walked. Displacement is the straight arrow from house to field. The distance is simply the three legs added up. 50 plus 40 plus 20, which is 110 meters. For the displacement, collect components. North 50 minus 20 leaves 30 meters north and 40 meters east. The magnitude is the root of 40 squared plus 30 squared. 50 meters, pointing north of east with tangent 3 by 4. Question 2. A particle starts at the origin, goes to 20 meters on the x-axis, then returns along the same line to minus 20 meters. Find the distance and the displacement for the whole trip. What does this mean? Distance counts both legs. Displacement only compares the final point with the start. Going out is 20 meters. Coming back from 20 to minus 20 is another 40 meters. The distance is 60 meters. The displacement is the final position minus the start, minus 20, minus 0. That is 20 meters in the negative direction. Question 3. Patna to Ranchi is 260 kilometers by air and 320 by road. The plane takes 30 minutes, the bus takes 8 hours. Find the average speed of each and the average velocity of each. What does this mean? Speed uses the path actually traveled. Velocity uses the straight line displacement of 260 kilometers for both. The plane flies the straight 260 kilometers in half an hour. Average speed, 520 kilometers per hour. The bus covers its 320-kilometer road in 8 hours. Average speed, 40 kilometers per hour. The displacement is the straight 260 kilometers for both. The plane's average velocity is 520 kilometers per hour from Patna to Ranchi. The bus's average velocity uses the same 260 kilometers over 8 hours. 32.5 kilometers per hour also directed Patna to Ranchi. Question 4. Leaving home, the car's meter reads 12,352 kilometers. Returning home 2 hours later, it reads 12,416. Find the average speed and the average velocity. What does this mean? The meter measures distance along the road, but he ends where he began. The distance driven is the difference of readings. 12,416 minus 12,352, which is 64 kilometers in 2 hours. So the average speed is 64 over 2, 32 kilometers per hour. But he returned to his starting point. The displacement is 0, so the average velocity is 0. Question 5. An athlete takes 2 seconds to reach his maximum speed of 18 kilometers per hour. What does this mean? Average acceleration is the change in velocity over the time taken, once units agree. First convert. 18 kilometers per hour is 18 times 5 by 18, which is 5 meters per second. He goes from rest to 5 meters per second in 2 seconds. Average acceleration 2.5 meters per second squared. Question 6. The speed of a car versus time is shown. It rises steadily from rest to 20 meters per second in 8 seconds. Find the distance traveled in 8 seconds and the acceleration. What does this mean? On a speed-time graph, the slope is the acceleration and the area under the line is the distance. The slope of the line is 20 meters per second gained over 8 seconds, 2.5 meters per second squared. The area under the line is a triangle. Half of 8 seconds times 20 meters per second, which is 80 meters. Question 7. A cart starts at t equals 0. Its acceleration is 5 feet per second squared for the first 10 seconds, 0 for the next 10, and minus 5 for the last 10. Find the distance traveled in 30 seconds. What does this mean? 3 phases: speeding up, coasting, braking to rest. Add the three distances. Phase 1, from rest at 5 feet per second squared for 10 seconds. Distance is half a t squared, 250 feet, ending at speed 50. Phase 2, constant 50 feet per second, for 10 seconds covers 500 feet. Phase 3 mirrors Phase 1. Slowing from 50 to rest covers another 250 feet. The total distance is 250 plus 500 plus 250, 1,000 feet. The position graph rises as a parabola, then a straight line, then flattens into a mirrored parabola. Question 8. The velocity time graph is a straight line, rising from 2 meters per second at t equals 0 to 8 at t equal 10 seconds. Find the acceleration, the distance in 10 seconds, and the displacement. What does this mean? Slope for acceleration, area for distance. The velocity never goes negative, so distance equals displacement here. The slope is the rise, 8 minus 2, over the run of 10 seconds, 0.6 meters per second squared. The area under the line is a trapezium. The mean of 2 and 8 times 10 seconds, which is 50 meters. The velocity stayed positive throughout, so the displacement equals the distance, 50 meters. Question 9. The x-coordinate versus time. Up to 50 meters by 2.5 seconds, flat to 7.5, up to 100 by 10 seconds, then straight down to 0 by 15. Find the average velocity from 0 to 10 seconds, and the instantaneous velocity at 2, 5, 8, and 12 seconds. What does this mean? Average velocity is net change over time. Instantaneous velocity is the slope of the segment you are standing on. From 0 to 10 seconds, x goes from 0 to 100 meters. Average velocity 10 meters per second. At 2 seconds, we are on the first rise. Slope 50 over 2.5, which is 20 meters per second. At 5 seconds, the graph is flat, velocity 0. At 8 seconds on the second rise, 50 meters gained in 2.5 seconds, 20 again. At 12 seconds, we are on the descent. 100 meters lost over 5 seconds, minus 20 meters per second. Question 10. The velocity time plot makes a triangle up to 5 meters per second in the first 20 seconds, then a mirrored triangle down to minus 5 in the next 20. Find the distance in the first 40 seconds and the average velocity. What does this mean? Distance adds the sizes of both triangle areas. Displacement lets them cancel. Each triangle has area, half of 20 seconds times 5 meters per second, 50 meters of travel. The distance is 50 plus 50, 100 meters. But the second triangle is below the axis. Displacement plus 50 minus 50 is 0, so the average velocity is 0. Question 11. The xt graph starts at 20 meters, slides down to 10 meters at t equal 10 seconds, then climbs steeply. Find the time t at which the average velocity from 0 to t is 0. What does this mean? Average velocity 0 means 0 net displacement. The particle must be back at its starting x of 20 meters. Average velocity vanishes exactly when x returns to its initial value, 20 meters. Reading the graph, the rising branch crosses the level of 20 meters at t equal 12 seconds. Question 12. A particle starts at A and travels along the curve shown. Find the position B, where the average velocity from A to B points along the instantaneous velocity at B. What does this mean? The average velocity points along the chord AB. The instantaneous velocity points along the tangent. We need the chord parallel to the tangent. The average velocity from A to B lies along the straight chord from A to B. The instantaneous velocity at B lies along the curve's tangent at B. Sliding along the curve, the chord and the tangent line up at about x equal 5 meters, y equal 3 meters. That is the point B. Question 13. An object moving at 4 meters per second is accelerated at 1.2 meters per second squared for 5 seconds. What does this mean? Constant acceleration with a running start. Use s equals ut plus half a t squared. Substitute u equal 4, a equal 1.2, t equal 5 into the distance formula. That is 20 plus 15. The object covers 35 meters. Question 14. A scooter at 43.2 kilometers per hour brakes with a deceleration of 6 meters per second squared. What does this mean? Convert to meters per second, then use v squared equals u squared minus 2as with final v0. 43.2 kilometers per hour times 5 by 18 is 12 meters per second. Stopping means v equals 0. The distance is u squared over 2a, that is 144 over 12, 12 meters. Question 15. A train starts from rest at 2 meters per second squared for half a minute, then the brakes bring it to rest in 1 minute. Find the total distance, the maximum speed, and the positions where the speed is half the maximum. What does this mean? Two phases on a VT triangle. The peak is the maximum speed, and half speed happens once on the way up and once on the way down. Phase 1, 2 meters per second squared for 30 seconds reaches 60 meters per second. That is the maximum speed. Distances, Phase 1 covers half of 2 times 30 squared, 900 meters. Phase 2, from 60 to rest over 60 seconds, covers half of 60 times 60, 1,800 meters. The total is 900 plus 1,800, 2,700 meters, or 2.7 kilometers. Half the maximum is 30 meters per second. On the way up, s equals 30 squared over twice 2, which is 225 meters from the start. On the way down, braking at 1 meter per second squared. 60 squared minus 30 squared over 2 gives 1,350 meters into the braking. That is 900 plus 1,350, 2,250 meters, 2.25 kilometers. Question 16. A bullet at 16 meters per second penetrates a tree trunk and stops in 0.4 meters. What does this mean? First, find the deceleration from the stopping distance, then the time from v equals u minus a t. From v squared equal u squared minus 2as with v0. A equals 16 squared over twice 0.4, which is 320 meters per second squared. Then the stopping time is u over a. 16 over 320, which is 0.05 seconds. Question 17. A bullet at 350 meters per second enters a concrete wall and stops within 5 centimeters. What does this mean? The same stopping formula, with the distance in meters, 0.05. With v equals 0, the deceleration is u squared over twice the distance. 350 squared over 0.1. That is 12.25 lakh, or about 12.2 times 10 to the 5 meters per second squared. Question 18. From rest, with constant acceleration, a particle reaches 18 kilometers per hour in 5 seconds. Find the average velocity and the distance covered. What does this mean? Under constant acceleration, the average velocity is just the mean of the endpoints. 18 kilometers per hour is 5 meters per second. The average of 0 and 5 is 2.5 meters per second. The distance is that average times the 5 seconds, 12.5 meters. Question 19. A driver's reaction time is 0.2 seconds. He is driving at 54 kilometers per hour, and the brakes decelerate at 6 meters per second squared. Find the distance covered after he sees the need to brake. What does this mean? 2 stretches. Full speed during the reaction, then braking to rest. 54 kilometers per hour is 15 meters per second. During the 0.2 second reaction, he covers 15 times 0.2, 3 meters at full speed. Braking from 15, distance u squared over 2a, that is 225 over 12, 18.75 meters. Together, 3 plus 18.75 is 21.75, about 22 meters. Question 20. Complete the braking table. 2 cars, deceleration 6 and 7.5 meters per second squared, and 2 drivers, reaction times 0.2 and 0.3 seconds at 54 and 72 kilometers per hour. What does this mean? Every cell is the same 2 formulas. Braking distance u squared over 2a, and total adds the reaction distance u times t. Car A, driver X at 54, u is 15. Braking 225 over 12 is 18.75, about 19 meters. Reaction adds 15 times 0.2, 3 meters, total about 22. Car A, driver Y at 72, u is 20. Braking 400 over 12, about 33 meters. Reaction adds 20 times 0.3, 6 meters, total about 39. Car B brakes harder, 7.5. Driver X at 54, braking 225 over 15 is 15 meters, plus 3 gives 18. Car B, driver Y at 72, braking 400 over 15 is about 27 meters, plus 6 gives 33. Question 21. A motorbike crosses a turning at 72 kilometers per hour. A police jeep follows at 90, crossing the same turning 10 seconds later. How far from the turning does the jeep catch the bike? What does this mean? When the jeep crosses the turning, the bike already has a head start. The jeep closes that gap at the difference of speeds. In meters per second, the bike does 20, the jeep 25. In its 10-second head start, the bike gets 200 meters ahead. The jeep gains 5 meters per second. Closing 200 meters takes 40 seconds. In those 40 seconds, the jeep travels 25 times 40 meters from the turning. 1,000 meters, 1 kilometer. Question 22. A car at 60 kilometers per hour overtakes one at 42. Each car is 5 meters long. Find the time of the overtake and the road distance it uses. What does this mean? Work in the slow car's frame. The fast car must gain 2 car lengths at the relative speed. The relative speed is 60 minus 42, that is 18 kilometers per hour, 5 meters per second. The overtake needs both lengths, 10 meters, so it takes 2 seconds. On the road, the fast car moves at 60 kilometers per hour, 16.7 meters per second, for those 2 seconds, and its own 5-meter length adds on, about 38 meters of road. Question 23. A ball is thrown straight up at 50 meters per second. Take g equal 10. Find the maximum height, the time to reach it, and the speed at half that height. What does this mean? At the top, the velocity is 0. Use v squared equals u squared minus 2gh. Maximum height, u squared over 2g, that is 2,500 over 20, 125 meters. Time to the top, u over g, that is 50 over 10, 5 seconds. At half height, 62.5 meters. V squared is 2,500 minus 2 times 10 times 62.5, which is 1,250. So V is 35 meters per second. Question 24. A ball is dropped from a balloon rising at 7 meters per second from a height of 60 meters. What does this mean? Dropped means released. The ball inherits the balloon's upward 7 meters per second, then gravity takes over. Taking down as positive. Initial velocity minus 7, acceleration 10, displacement 60 meters. Then 60 equals minus 7t plus 5t squared. Solving the quadratic. T equals 7 plus root of 49 plus 1,200 over 10. The root is about 35.3, so t is about 4.3 seconds. Question 25. A stone is thrown straight up at 28 meters per second. Find the maximum height, the velocity 1 second before the top, and whether that changes for initial speeds like 40 or 80. What does this mean? Time reverse the last second. Falling from rest for 1 second always gives the same speed. Maximum height, 28 squared over twice 9.8, which is 784 over 19.6, 40 meters. 1 second before the top, the stone has exactly 1 second of deceleration left. Its speed is g times 1, 9.8 meters per second. That reasoning never used the initial speed. Whether u is 28, 40, or 80, the last second before the top is identical. The answer does not change. Question 26. From a tall building, balls are dropped at 1 second intervals. When the 6th ball is being dropped, where are the 3rd, 4th, and 5th? What does this mean? At that instant, the 5th ball has fallen for 1 second, the 4th for 2, the 3rd for 3. Use half gt squared. The 5th ball is 1 second old. Half of 9.8 times 1 is 4.9 meters below the top. The 4th ball is 2 seconds old. Half of 9.8 times 4 is 19.6 meters below. And the 3rd ball, 3 seconds old. Half of 9.8 times 9, which is 44.1 meters below the top. Question 27. A young man stands 7 meters from an 11.8 meter building. A kid slips from the top. He must catch it at arm height, 1.8 meters. What does this mean? The kid falls freely through 10 meters. The man must cover his 7 meters in exactly that fall time. The kid falls from 11.8 down to 1.8, a drop of 10 meters. Free fall time, root of 2 times 10 over 9.8, which is root 2, about 1.42 seconds. To cover 7 meters in that time, he must run at 7 over 1.42. About 4.9 meters per second. Question 28. An NCC parade marches at 6 kilometers per hour under a berry tree. A bird at 12.1 meters drops a berry. Which cadet, at what distance from the tree, receives the berry? What does this mean? The berry takes a fixed fall time. The cadet who is that marching time away arrives just as it lands. The berry falls 12.1 meters. T is root of 2 times 12.1 over 9.8, root of 2.47, about 1.57 seconds. The parade moves at 1.67 meters per second. The cadet, now 1.67 times 1.57, about 2.62 meters from the tree, walks under the berry as it arrives. Question 29. A dropped ball crosses its last 6 meters in 0.2 seconds. Take g equal 10. Find the height it was dropped from. What does this mean? First find the speed entering that last stretch, then how far it had already fallen to gain that speed over the last stretch. 6 equals v1 times 0.2 plus half of 10 times 0.04. So v1 is 6 minus 0.2 over 0.2, 29 meters per second. To reach 29, from rest, the ball had fallen 29 squared over 20, 42.05 meters. Adding the final 6 gives about 48 meters. Question 30. A ball falls 5 meters onto sand and stops 10 centimeters deep. Find the uniform retardation in the sand. What does this mean? The fall sets the impact speed. The sand must remove all of it within 0.1 meters, falling 5 meters. V squared is 2 times 9.8 times 5, which is 98. Inside the sand, that 98 must vanish in 0.1 meters. A equals 98 over 0.2, which is 490 meters per second squared. Question 31. An elevator descends with uniform acceleration. As it starts, a person drops a coin from 6 feet above the floor. It strikes the floor in 1 second. Find the elevator's acceleration. What does this mean? Work in the elevator's frame. The coin falls at g while the floor falls away at a, so the coin approaches the floor at g minus a. Relative to the elevator, the coin accelerates downwards at g minus a. It must cover the 6 feet in 1 second. So g minus a is 12 feet per second squared. With g equal 32, the elevator's acceleration is 20 feet per second squared. Question 32. A ball is thrown horizontally at 20 meters per second from 100 meters up. Find the time of flight, the horizontal distance, and the striking velocity. What does this mean? The vertical fall fixes the time. The horizontal motion just runs at 20 for that long. Vertically, it is a pure 100-meter drop. T is root of 2 times 100 over 9.8, about 4.5 seconds. Horizontally, 20 meters per second for 4.5 seconds is 90 meters. At landing, the vertical speed is 9.8 times 4.5, about 44.3. Combined with the horizontal 20, root of 20 squared plus 44.3 squared, about 49 meters per second. Its direction, tangent inverse of 44.3 over 20, about 66 degrees below the horizontal. Question 33. A ball is thrown at 40 meters per second at 60 degrees above the horizontal. Take g equal 10. Find the maximum height and the range. What does this mean? Split u into components. U sine theta climbs, u cosine theta carries it forward. Maximum height, u sine 60 squared over 2g. U sine 60 is 40 times root 3 over 2, about 34.6. Squared over 20, 60 meters. Range, u squared sine 120 over g, that is 1,600 times root 3 over 2, over 10. 80 root 3 meters, about 138.6. Question 34. A football, 40 yards from 10-foot goalposts, is kicked at 64 feet per second at 45 degrees. Will the ball reach the goalpost? What does this mean? Follow the parabola to x equal 120 feet and see how high the ball still is. 40 yards is 120 feet. The trajectory height is x tangent theta minus gx squared over twice u squared cosine squared theta. Substituting x 120, u 64, g 32. Y is 120 minus 32 times 14,400 over 4,096. That is 120 minus 112.5. 7.5 feet. 7.5 feet is under the 10-foot bar, so yes, the ball reaches the goal, passing below the crossbar. Question 35. A goalie is projected horizontally from 19.6 centimeters height at a target goalie 2 meters away on the ground. What speed makes it a direct hit? What does this mean? The drop time comes from the 0.196 meter fall. The speed must carry it 2 meters in that time, falling 0.196 meters. T is root of 2 times 0.196 over 9.8, which is root of 0.04. Exactly 0.2 seconds. To cover 2 meters in 0.2 seconds, the launch speed must be 10 meters per second. Question 36. A ditch 11.7 feet wide has approach roads at 15 degrees. A 5-foot bike leaves the road when its front runs out. What minimum speed crosses it safely? What does this mean? The bike is a projectile launched at 15 degrees. It must span the ditch plus its own length. Since the bike leaves when its front runs out, the rear must clear too. The needed range is 11.7 plus 5, which is 16.7 feet. With launch angle 15 degrees, the range formula gives u squared equals rg over sine 30. That is 16.7 times 32 over half, about 1,069. Taking the route, about 32 feet per second is the minimum speed. Question 37. From a 171-foot cliff, a packet is thrown at 15 feet per second, aimed directly at a friend 228 feet away on the ground. How short of the friend does it fall? What does this mean? Aiming down the line fixes the launch direction below the horizontal. Gravity then pulls the packet under that line. The aim line drops 171 over a run of 228, tangent 0.75, so the throw points 37 degrees below horizontal. Components: 12 forward, 9 down. Falling 171 feet. 171 equals 9t plus 16t squared. That solves to t equal 3 seconds. In 3 seconds, it travels 12 times 3, 36 feet outward. The friend is at 228, so it falls short by 192 feet. Question 38. A ball leaves the floor at 15 meters per second, 60 degrees up. A vertical wall stands 5 meters away. Does it hit the wall in the air? And does the answer differ for a wall 22 meters away? What does this mean? Compare each wall distance with where the ball is still airborne. Its range. The range is 15 squared times sine 120 over 9.8. 225 times 0.866 over 9.8, about 19.9 meters. A wall at 5 meters is well inside that range, so the ball is still flying when it arrives there. Yes, it hits the wall. A wall at 22 meters is beyond the range. The ball lands on the floor at about 19.9 meters before reaching it. So yes, the answer differs. Question 39. A projectile launched at speed u, angle theta, crosses half its maximum height twice. Find the average velocity between those instants. What does this mean? Between the two crossings, the vertical displacement is 0. Only the horizontal motion contributes. The two crossings are at the same height, so the net vertical displacement between them is 0. The horizontal velocity is constant at u cosine theta throughout. So the average velocity is u cosine theta, horizontal, in the plane of the flight. Question 40. A bomb is dropped from a plane flying horizontally at uniform speed. Show it explodes vertically below the plane. And is that still true if the uniform velocity is not horizontal? What does this mean? Compare the horizontal motions of the plane and the bomb after release. At release, the bomb shares the plane's horizontal velocity, and gravity never changes horizontal motion. Both keep the same horizontal velocity forever. Equal horizontal velocities from the same point mean equal horizontal positions at every instant. The bomb stays exactly below the plane and explodes there. If the plane climbs or descends at uniform velocity, the horizontal components still match forever. So the statement remains true. Question 41. On a railroad car accelerating at 1 meter per second squared, a boy throws a ball straight up at 9.8 meters per second. How far behind him does it land on the car? What does this mean? In the car's frame, the ball drifts backwards at 1 meter per second squared while it flies. The flight time is twice 9.8 over 9.8, 2 seconds up and down. Relative to the car, the ball has a backward acceleration of 1 meter per second squared. In 2 seconds, it slips back half of 1 times 4, 2 meters. Question 42. A staircase has 3 steps, each 10 centimeters high and 20 wide. A ball rolls off the top horizontally. What minimum speed lets it hit the lowest plane directly? What does this mean? To skip the middle steps, the ball must clear the edge of the last intermediate step. 0.4 meters across, while falling at most 0.2 meters. The critical corner is 2 steps across and 2 steps down. 0.4 meters out, 0.2 meters below the launch level. Falling 0.2 meters takes root of 2 times 0.2 over 10, 0.2 seconds. Crossing 0.4 meters in that time needs at least 2 meters per second. Question 43. A truck moves at a constant 14.7 meters per second. A man on it throws a ball that returns to the truck after it has moved 58.8 meters. Find the speed and angle of the throw, as seen from the truck and as seen from the road. What does this mean? Returning to the truck means the throw was straight up in the truck's frame. The road adds the truck's velocity. The truck covers 58.8 meters at 14.7. The flight lasted 4 seconds. From the truck, the ball went straight up and back in 4 seconds, up for 2. Its launch speed was g times 2, 19.6 meters per second, vertically upward. From the road, add the truck's 14.7 horizontal. Speed root of 14.7 squared plus 19.6 squared, which is 24.5 meters per second. Its angle, tangent 19.6 over 14.7 is 4 by 3, so 53 degrees with the horizontal. Question 44. A batsman, striking 1 meter above ground, hits a sixer at 35 meters per second, 53 degrees up. The gallery benches, 1 meter wide and high, start 110 meters away. Which bench does the ball hit? What does this mean? The bench staircase rises 1 meter per meter. Find where the falling ball meets that staircase. Components: 35 cosine 53 is 21, 35 sine 53 is 28. Bench K's floor is at height k minus 1 above the strike level, at distance 109 plus k. With x equal 21t and y equal 28t minus 5t squared, eliminating k gives 5t squared minus 7t minus 110 equals 0. So t is about 5.44 seconds. Then x is 21 times 5.44, about 114.3 meters. That is 5.3 meters into the gallery, inside the 6th bench's slab. The ball lands on the 6th bench. Question 45. A man 5.5 meters from the center of a 1 meter boat throws an apple at exactly 10 meters per second. Find the minimum and maximum projection angles that land it in the boat. What does this mean? The apple must land between 5 and 6 meters. Pin the range formula between those bounds. The boat spans 5 to 6 meters away. The range is 100 sine 2 theta over 9.8, so sine 2 theta must lie between 0.49 and 0.588. Sine gives 2 windows, 2 theta near 30 degrees or near 150. So theta is about 15 degrees, the flat throw, or about 75 degrees, the steep lob. The minimum angle is about 15 degrees and the maximum about 75. The band in between overshoots or, rather, angles between roughly 18 and 72 degrees throw the apple past the boat. Question 46. A 400-meter river flows at 2 meters per second. A boat sails at 10, perpendicular to the river. Find the crossing time and how far downstream it lands. What does this mean? The 10 crosses, the 2 drifts. Each component works alone. Crossing 400 meters at 10 meters per second takes 40 seconds. In those 40 seconds, the current carries it 2 times 40, 80 meters downstream. Question 47. A 500-meter river flows at 5 kilometers per hour. The swimmer does 3 with respect to water, heading at angle theta with the flow. Find the crossing time and its shortest possible value. What does this mean? Only the component across the river, 3 sine theta, does the crossing. The crossing component is 3 sine theta. Half a kilometer over that speed, t equals 0.5 over 3 sine theta hours, which is 10 over sine theta minutes. Sine theta peaks at 1 when he heads straight across. The shortest time is 10 minutes. Question 48. Same river. The swimmer must end directly opposite, walking along the bank whatever the drift. Minimize the walk. What does this mean? He cannot cancel the 5 flow with 3. Some drift is unavoidable. Choose theta to minimize drift, not time. Heading at theta with the flow, the drift is the downstream speed, 5 minus 3 cosine theta, times the crossing time. Differentiating and setting to 0 gives cosine theta equal 3 by 5. Then the drift is 5 minus 1.8 times 0.5 over 2.4, 2/3 of a kilometer. That is the minimum walk. Question 49. A plane must fly 500 kilometers, 30 degrees east of north, in a 20 meter per second north wind, with airspeed 150. Find the heading and the flight time. What does this mean? The wind's component across the track must be cancelled by heading slightly into it. The wind splits along and across the track. Along, 20 cosine 30, about 17.3. Across, 20 sine 30, which is 10, pushing west of track. To cancel the 10, the pilot heads east of the track by sine inverse of 10 over 150. Sine inverse of 1 by 15. Along the track, the speed is 150 cosine alpha plus 17.3, about 167 meters per second. 500 kilometers over that is about 3,000 seconds, 50 minutes. Question 50. Friends A and B stand X apart, wind blows from A to B. Sound downwind arrives T1 after the flash. After swapping places upwind, it takes T2. Find the speed of sound V and the wind speed U. What does this mean? The wind carries sound. Downwind it travels at V plus U, upwind at V minus U. Downwind, X over V plus U equals T1. Upwind, X over V minus U equals T2. So V plus U is X over T1, and V minus U is X over T2. Adding and having gives V, subtracting and having gives U. Question 51. Now A and B stand, so the line joining them is perpendicular to the wind, still X apart. What is the lag between seeing and hearing? What does this mean? The sound that reaches B is the wavefront aimed slightly upwind, so its along line speed shrinks. For sound to travel straight along AB, its velocity through air must tilt upwind, so the crosswind U cancels. The component that remains along AB is root of V squared minus U squared. So the lag is X over root of V squared minus U squared. Question 52. 6 particles at the corners of a regular hexagon of side chase each other at constant speed V, each aiming at the next corner. When do they meet? What does this mean? By symmetry, they spiral into the center. Watch how fast the separation between neighbors shrinks. Consider one particle and its target. The chaser moves at V along the line joining them. The target's velocity makes 60 degrees with that line. Cosine 60 is a half, so the gap closes at V minus V by 2. V over 2, and this rate stays constant by symmetry. Closing a full side at V over 2 takes 2A over V. That is when all 6 meet at the center. That completes Chapter 3, Rest and Motion, Kinematics from Concepts of Physics by H C Verma, both objective sections and all 52 exercises. In the next video, we take up Chapter 4, The Forces. Thank you for watching. If this helped, do like the video, subscribe to Math is Beautiful, and share it with your friends.